I'm Abu Bakr Ali, your physics teacher, and today we are going to solve some past paper questions from the topic of dynamics, AS physics. So let's begin with the first question. In the question, they're asking the diagram shows a uniform plank XY, and its length is 4 meter and its weight is 300 Newton. As it is a uniform plank, so its weight will be exactly at the middle, that is 300 newtons, right? The plank rests on a fixed support at the end x and y. There is a x, there is a y. Okay. So the support at x exert a force F vertically upward on the plank. So there is a force F like this. It will be, let me make it this way so we can see the x as well. There is a force F. Okay. We named it F. What is the magnitude of F when the child stand at X and when the child stand at Y? Okay, so we have to comment about this force that I have drawn there. Okay, as the plank is uniform, its weight will be acting at the middle, and from middle this X and this Y, they both are at the same distance from where the plank is supported. So its weight will be divided. The 150 weight will be acting there, and its 150 weight will be acting there. Okay, it will be equally divided because both the sports have an equal distance from the center where the weight is acting. Okay, so all the time this 150 force will be acting here, right? And to counter this force there will be a 150 force upward. This will be all the time. Okay, so when the child is standing at the point x, when he is standing exactly at this point, child's weight is, it's given, it's 600 newton. So in this 150, this 600 newton will also be included, right? Remember the action and reaction, Newton third law. The amount of force exerted down on the same should be exerted upward. So it will be 750 when the child is standing at x. So these are the two options that we have. So we have to choose between C and D. And when the child is standing at position y, okay, so now you are removing this force from here. The child will be at y, so it will be exerting 600 newton force here. So there will be no force because of the child at point x, because the child is standing at y. All of the force of the child will be exerted at y. So there will be only one force, that is of plank. So it should be 150. So it's option D. Okay, let's move to the next question. And the next question, which door describe a pair of forces that forms a couple? Okay, what was the couple? Couple is basically when two equal but opposite forces acts on an object and it starts rotating. Okay, and their line of action of forces should be different. So it's should be equal, it should be opposite. So it's option B. In the third question, a uniform cylinder of weight 25 Newton is suspended from a Newton meter. The cylinder is fully submerged into the water as shown in the diagram. The reading on the Newton meter is 10 Newton. Okay, now there is a concept. The force exerted by the object downward, this thing, will be its weight. That is given, that is 25 Newton. Okay. Let's suppose if there is only this Newton meter and there is this thing hanging with it. If its weight is 25 Newton, then this needle will also show you the 25 Newton. Okay. But when this thing is submerged into some liquid, what is happening there? Your this reading will decrease. It will not be showing you the actual weight. It will tell you the resultant force basically. Why? Because when this thing is submerged into the liquid, there will be a force acting upward that is called upthrust. So there will be a upthrust acting on the object, and this thing that the needle will show, that will be the resultant force, because all of the weight is not acting on the spring balance, right? Newton meter. So what we know, there are two forces, downward and upward. So if you weight minus the upthrust, okay, that will give you the reading on the Newton meter, you can say the reading on it. So reading is basically 25, no, the reading is 10, weight is 25, and upthrust. Okay, from there you can get that upthrust will be equals to 15 Newton. Okay, what they're asking us, the water is replaced by a liquid with a density 10% greater than the density of the water. Okay, so if you remember the relation for the upthrust, the upthrust force is density into g into v. So I can say that upthrust is directly proportional with the density. Okay, so if the density is 10% increased, the upthrust will also be 10% increased. So the new upthrust will be upthrust plus, let me move it from here, plus 10% of upthrust previous value. Okay, because it's increased upthrust by 10%, so it will be 15, and 10% of 15 is 1.5, that will give you 16.5 Newton. Okay, and now you have to tell what is the new reading on the Newton meter. So new reading will be equals to weight minus new upthrust. So weight is basically 25 minus 16.5, that will give you 8.5. So it's option A. Okay. Okay. In question 4, a student balances a 30 centimeter ruler on a fulcrum set at the 15 centimeter mark. She then places a 50 grams of mass at the 23 centimeter mark and 20-gram mass at the 11 centimeter mark. What mass should she place on the 7 centimeter mark to restore the balance? Okay, so you have to find the mass of this object. So if you see, first you have to see how many forces are acting. One force will be acting because of this mass. Let's call it M. Okay. So it will be exerting force mg. One force will be because of this mass. It will be 20g. One force will be because of this mass. This will be 50g. Okay. Force is their weight, and weight is basically mass times gravity. Okay. Okay, these are in grams. You can convert them into the kg if you want to, but it does not make any difference in the movement questions. Okay, I'm not changing the units because I have to write on the all the options are on or also in the grams. Okay, so to find the movement, what distances we need? We need, this is the pivot point. We need this distance. Okay, we need this distance, and we need this distance as well. Okay, from the pivot point till the point of application of force. So as this is total 30 and the ruler is placed at this point is 15, so 15 to 23 is 8 centimeter, this will be 4 centimeter, and this will be till the 7, it is 8 centimeter. So let's apply the moment relation. Total clockwise movement should be equals to total anti-clockwise movement. So if you observe, this is clockwise and these two are anti-clockwise. So clockwise movement is force, that is 50 g, into the distance, that is 8. Again, I'm not changing the units of the distance as well because that does not matter. Okay, they all should be in the same unit, so they are in centimeters, so we can do it. And anti-clockwise movement for the 20 g is 20 g is the force, the weight of the object, and the distance is 4. Then again plus mass is m multiplied by g, and the distance is 8. Okay, so if you see, the g is common in all of them, so if you take the g common, they will be cancelled out. Okay, so what does it mean? Instead of force, you can simply multiply this thing with the masses as well. Okay, so it will have the same answer in that case. So what we have to do, 50 into 8 is equals to 50 into 8, and this thing will be subtracted on the left side, so minus 20 into 4 divided by 8. That will be your mass, and that will be 40 grams. Okay, so B is the answer. And the next question, a submarine is at a depth of 130 meter below the surface of the sea. So you have the depth. The pressure on the submarine due to the seawater is P. Then the submarine sink to the depth of 260 below the surface. Assume the density is same. What is the difference between the pressure on the submarine due to the sea water at the two depths? Okay, so the difference in pressure is basically density g into difference in depth simply. Okay, because density and g both are constant. So density is rho g, and change in depth is basically it is 260 minus 130. That will give you rho g into 130. Okay, that is a change in pressure, but we don't have this option here, so we have to look at what they were telling us. When the pressure was when the depth was 130, the pressure was p. So at 130, this p is basically density was pressure in the liquid is p rho g, and the depth was 130 for this thing. So this thing is equals to p, so we can call this thing as p. So change in pressure is equals to p. Okay. The next question, a wooden block is held stationary in a container of water using a string that is attached to both the wooden block and the bottom of the container. The wooden block has mass m and a volume v. The water has a density rho. The acceleration of the free fall is g. What is the magnitude of the force acting on the block due to the tension in the string? Okay, so you have to find the tension. So let's look at the block and try to draw some free body diagram for it. If this is the block, what are the forces acting on it? First, there is a force of weight that will be acting downward. Okay, so why it's not going down? It's hanging at the middle of the water body. Why? Because there is some upthrust force that is acting upward. So this is the upthrust. Okay, and it is attached with the string, and string is also trying to hold it. It's not letting it go upward. So there is another force, that is the tension. It will also be downward. Okay, towards the fixed end of the string. So if you see, What is one force is upward and two forces are acting downward, and this thing is not moving, it is stationary, right? It is in equilibrium. So it's mean upward forces should be equals to downward forces. Upward force is up thrust, let me write it as up T, and downward is tension plus weight. I have to write for the tension, so tension is equals to up thrust minus weight. For up thrust, we know it is rho g v, and weight is mg. So it's option D. In the next question, shop sign of uniform density has a mass of 2.4 kg and a side of length this. So we have a mass, we have a length. The sign is supported by a hinge along its top end. There is a hinge. Okay. There is a friction in the hinge so that the sign hangs from its equilibrium at an angle of 15 degrees. So this is the angle that is given. What is the movement about the hinge of the weight of the sign? So we have to find the movement because of the weight. So let's try to solve this thing. If you see, this is a uniform rod. If this total length is 0.86, this will be the point where the weight is acting, right? So I can say there's a force acting on it like this, that is its weight. And this should be from the pivot point, this length should be half of 0.86, right? Because that is, this is at the middle. This will be 0.43 meters. Okay. So we have to find the moment. We have the force, that is its weight. Weight will be equals to mg. We need the distance. So for the trick, what you need to know, if the line of action of force you see it is like this, you have to imagine a line that is parallel to the line of action of force and it should pass to the pivot point. Okay. So this is the line. So if you see both the lines, the line of action of force, this one, and the line that I have imagined, they both are parallel, and this line what I have imagined is passing through the pivot point. Okay. So what distance you need to find the moment? You need the distance between these two lines. This distance is required. Okay. So how I can find this distance? If you see what this thing is making, I'm going to consider this portion. So this thing is like this. This distance is 0.43. This angle is 15. And what I need? I need this from there to there. Okay. So this will be, D will be 0.43 sine of 15. Okay. It will be sine of 15. And this side will be cos of 15 because this is the base. It is attached with the angle. Okay. So this is the distance and you have the force, so you can find the moment. Moment we know it is F into D. F is weight mg and D is basically 0.43 sine of 15. Mass is given 2.4, G you know 9.81, 0.43 multiplied by sine of 1.5. Okay. So when we calculate the answer, it will give us 2.62. So this is option A. In the next question, a block is submerged vertically in a liquid. The four diagrams shows the block viewed from the side. Which diagram shows the scale the forces exert on the equal area of the block by the liquid? Okay, they are showing to the scale. So the length of the line is showing the magnitude of the force. Okay, so if you see in option B, there is these all the objects, they are all submerged in the liquid, so they are all in the liquid like this. Okay, so when something is in the fluid will exert a force from all the sides. Okay, so first thing, we this is the wrong option, the option B. Okay, now we know the force is, or the pressure is, rho g h. What is this thing? This thing is the depth. So more depth, more pressure, it's mean there will be more force. So if you see in these diagrams, this they all have the same length. It's mean they all, if this is the liquid surface, if I draw it like this, if this is some container, so you can imagine all of them have the same depth from the in the liquid. They have the same depth, they have the same, so these all points should have the same pressure. But if you see this point have a different depth comparatively, like its depth is from this point to this point, its depth is more, its depth is even more, its depth is even more, and as the depth is increasing, the force is increasing. So this thing is making sense. Okay, and again these arrows are the longest and they are equal with each other, so it's they are because they all are at the same depth in the liquid, right? So this will be the option. In the next question, the diagram shows a couple. How is the torque of the couple calculated? Okay, so if this is the couple, this is the force, this is the force, and the distance between them is this, the relation is simply you will multiply with the force and this distance. That's it, that will give you the couple. So perpendicular distance between the forces and magnitude of one of the force. Okay, so it's option B. In the next question, a non-uniform bar PQ has a length of 50 centimeter and a weight of 200 Newton. Okay, and the bar is non-uniform. It means its weight is not acting at the middle. Okay, a block of weight 400 Newton is attached to the top of the bar at its center. Okay, so block is placed at the center and block's weight is given, that is 400 Newton. Okay, the bar rests on a horizontal ground. A vertical force of 360 Newton is acting. Okay, and it's shown here, and it's just sufficient to lift the end q. It's mean they are balanced. Okay, so the movements are balanced basically. What is the distance from the center of gravity of the bar to the end p? You have to tell this thing from the center of, acha, center of gravity can be anywhere, we don't know where it is because the rod is non-uniform. So we can imagine at any point, let's suppose it is at this point somewhere. Okay, and I can name this distance as x. Okay, from x, from p, and that is what you have to find as well. Okay, so what we can do, we can take the case of movement and we can imagine if you apply a force at this point, so the rod will be lifted upward. So it will be like, if you imagine, it will be somehow like this. So the rod will be like this if you're applying a force at this point, right? So this is the point that will remain at its position about which the body is rotating. So this point is taken as pivot. Okay, so this is the pivot point. Okay, so when we are considering the movement, we have the three four. This force will be the weight of, they will be the weight of 200 Newton that will be acting. Okay, and as this 400 Newton, the block is placed at the center. So total rod is 50 centimeter. That should be 25 centimeter, then half of the length. Okay, So what we know, the clockwise movement, total clockwise movement must be equals to total anti-clockwise movement. So this thing is producing anti-clockwise movement. This is producing clockwise, and this is also producing clockwise movement. So total clockwise movement, if I write down, it will be 400 multiplied by the distance from the pivot is 25. Again, I'm not changing the units, plus 200, and the distance is x, is equals to the anti-clockwise movement, that is 360, and the distance is equals to total length of the rod, that is 50. Okay, so we have to solve it for the x. So 4,400 into 25 is 10,000, plus 200x is equals to 1800. So x will be equals to, this will be going on that side, so you will get 8,000 divided by 200. Okay, let me check, there is some mistake in the calculation, I guess. When you multiply 360 with the 50, you will get, okay, it's 18,000. Okay, so okay, it will be, so this will give you 40 centimeter. Answer will be in centimeter. Why? Because I have used all the data in centimeter. This was in centimeter, centimeter, this was in centimeter. Okay, so 40 centimeter, that can be written as 0.40 meter. It's option D. In the next question, what is the definition of the density? Density can be defined as mass per unit volume. Okay. In the next question, a block is in equilibrium on a slope. Which vector triangle represents the three forces acting on the block? Okay, this is in equilibrium. It's mean sum of forces should be zero, or you can say resultant should be zero. Okay, so when the resultant will be zero, when the forces are making a cyclic triangle. How the cyclic can be, like, they, this is moving like this in that direction, and then if you see, their heads are facing each other, so that is not a cyclic. Okay, so if you see this one, okay, there it is going, then it's again their heads are facing each other. So when the heads are facing each other, they will not give you a zero resultant. If you see this one, it goes there and it goes there. So this is making a cycle. How it is making a cycle? This one is going there, then this is going there, this is going there, then again they are in a cycle. So this thing will give you a zero resultant, so it's option C. In the next question, a measuring cylinder contain 80 centimeter cube of a liquid. The pressure due to the liquid at the 60 centimeter cube mark is 1200 Pascal. What is the pressure due to the liquid at the base of the measuring cylinder? Okay, so this is about the measuring cylinder. So let's first imagine it. There is some measuring cylinder, and there is some liquid inside it. Okay, and what they're telling, the total, it have 80 centimeter cube of liquid. Okay, when the object is at 60 centimeter cube of reading, at this point I can say what they have given is 1200 Pascal of pressure. They're asking when the object is at this point, what will be the pressure? Okay, so if you see, we know pressure depends on the depth. Okay, so it's directly proportional with the depth. So if it is at this point, the depth is basically 80 minus 60, that is 20. But when it is at this point at the bottom, the depth will be 80 minus 0, that is 80. Okay, so I can write as when the depth is 20, pressure is 1200, and when the depth is 80, what will be a pressure? Okay, so x will be equals to 1200 multiplied by the 80 divided by the 20. So this thing will give you 4800 Pascal. Okay. In the next question, an astronaut of mass m in a spacecraft experiences a gravitational force mg when stationary on the launch pad. What is the gravitational force on the astronaut when the spacecraft is launched vertically upward with an acceleration of zero point 0.2 grams? Okay. So what you have to tell the gravitational force. Okay. Gravitational force initially it was mg. Acha, if there is a spacecraft, it's at rest, its weight will be equals to m into g. Now it is moving, again its weight will be mg. It will not make any difference. It's the weight of the air astronaut depends on the gravitational field strength or the gravitational acceleration. It does not depend on the acceleration of the spacecraft. Okay, so the actual weight of that and the apparent weight can change, that is another story, but they haven't asked you that thing. So the weight will be the same, it is mg. Okay. In the next question, the diagram shows a child x of mass 20 kg and a child of mass 15 kg seated on a uniform plank. The plank has a mass of 7 kg and has a pivot at its midpoint. The plank is horizontal and is in equilibrium. Which statement about the weight of the plank is correct? Okay, so the weight of the plank can be considered to be acting at its midpoint. Okay, how we can consider this thing? It is, if you see, the plank is supported from the middle point, right? And both the childs are stable, they are in equilibrium condition. Apparently, this distance is less, this distance is more, but where the distance is less, the mass is more, and where the distance is more, the mass is less. And if you remember, there will be a weight of this child, weight of y, there will be a weight of x. So both the movements are balancing each other with the principle of movement. Okay, so there is a high possibility that this thing is placed at the center. Secondly, if you see what they have told us, it's a uniform plank. So for each symmetrical object or the uniform plank, the weight always lie at the center simply. So it is option A. In question 16, an object is fully submerged in a liquid. A student determines the ratio of thrust acting on the object over a weight of the object. Which single change would double the value of this ratio? Okay, so first we need to understand what this ratio is. We know the upthrust is basically, this thing is rho g v, right? Upthrust force. The weight is basically the mg. Okay, we can simplify this thing further. How? The mass can be, so if you see this equation, this depends on the density, the volume, the mass, and the gravity. This g can be cancelled out with each other, right? So we can cancel this G with the G. So it will give you density into volume divided by the mass. Okay, let's see the options. Use a different liquid that has twice the density and same volume as the original. So if this thing is twice, so the whole equation will be 2 rho V over M. So the whole equation will be twice as compared to before. So it will double that. Yes, that was a requirement. Okay. Then they're asking use a different object that has a half the volume and same density. No, that will half the ratio. We need to check when it will be double. Okay. So A is the option. C and D are also not correct. In the question 17, a shop sign weighing 75 Newton hangs from a frame attached to the vertical wall. The frame consists of a horizontal rod XY and YZ that is at an angle of 30 to the horizontal. Rod XY is attached to the wall by a hinge at the point X and has a length of 0.5. This all data is also shown on the diagram. What is the horizontal force exerted by the wall on the road? So you have to tell this force that is exerted by the wall on the rod. Okay, this will be equals to the same force that the rod is exerting on the wall. They are the action reaction forces, right? So we need to find this force. They both will be equal. So let's first analyze what the scenario is given. This thing is hanging and there is a force that is its weight acting on it, 75 Newton. And there is a tension in the string. This is a string. This string is trying to hold this thing. So there will be a tension in it. So if you see this weight is not moving up or down, so it is in equilibrium as they have told you. So its downward force will be balanced by the upward force. There will be some force upward that will be equals to the weight because they are both balanced. Same as if there is force in this direction, right? Okay. So what we have to find this thing. So this is the tension and this is its one component, this is its second component, but the challenge is we don't have the tension as well. Let's try to find it out. So the x component, sorry, let's write the y component first because we know what the y component is. This is basically t sine of 30, and we know as they are balanced, so t sine 30 should be equals to weight. So I can write T is equals to weight divided by sine 30 and weight is 75. Okay. So this thing will give us the value of tension that will be equals to 150 Newton. Now we know the tension. What I have to find, I have to find basically this force, this component. So this is basically T cos 30. Okay. So T is 150 cos 30. So 150 cos 30 give you 129.9. That is 130. Okay. So that's it for the paper 2025. In the next video, we will solve the question from the paper 2024.